Welcome to today's lesson on trigonometry ratio for angle greater than 90 degree. In this video, we will dive into how trigonometry extend beyond the standard range of angles and explore its practical applications, including its role in operating machinery, and so forth and so on. Why we need to learn this? Before we begin, let's briefly discuss why understanding trigonometric ratio is important. Trigonometry is a fundamental branch of mathematics used in various fields, from engineering to construction. By mastering knowing trigonometric ratio, we can solve a complex problem and make important decision in our life. So let's start by reviewing the basics. Trigonometric ratio, including sine, cosine, and tan, are mathematical functions that relate the angles of a right triangle to the length of its sides. So while trigonometry ratios are commonly associated with angles between 0 and 90 degree, they can also be used we can expand them to how to calculate this ratio for angle in different quadrants bigger than 90 degree. For instance, if we plot a point A, which has 3 as x on the x-axis and 4 as y-axis, on the y-axis is 4. So in which quadrant does the point A lies? So let's do that. So first of all, we will just draw our x and y axis like this. Okay. Now let's take some points from there. So this is 1, 2, 3, 4. This is 3. 1, 2, 3, 4. So this is 4. Minus 1, minus 2, minus 3, minus 4, minus 3. Minus 1, minus 2, minus 3, minus 4. This is minus 4. So the first point we have is A, which has 3 in x-axis and 4 in y-axis. So 3, 4. So the first thing they are asking us to draw is draw a line perpendicular to x-axis through A. So let's first draw our our angle like this. So we will connect our origin, which is O, which is 0, 0, to the point A, and then we will draw a perpendicular line to the x-axis, which is this. So this is our, no, this is not quite good. So let me redo it again. Okay, I don't know why it's a little bit not on the right place. Okay, no problem. This is my A, this is my, and name it what they are telling us to name it is to name it B. So I will name it B. Okay, is on the initial arm. The angle AOB. So my angle AOB is this angle, which I will just this is my angle, which have O in its center. Okay, Use the Pythagorean theorem to determine the length of the hypotenuse R. So this is my R. So this is R. This is, I know this is 4 and this is 3. Okay, so if you want, we can remove this 3 here and we just put this 3 to show us this is the length, this is 3. Perfect. So now we need to calculate R. To calculate R, we need to use the Pythagorean theorem. So R square is equal to 4 square plus 3 square, which is 16, plus 9, which is 25. So our R is square root of 25, which is 5. So for R, oh no, R is equal to 5. We just find that. So let's remove this thing. We don't need them anymore. Now we write the primary trigonometric ratio of theta. So theta, the sine of theta is the opposite, which is this, over the adjacent, which is this, not over the hypotenuse. So sine of theta is the opposite over the hypotenuse, which is how much? 4 over 5. The cos of theta is the adjacent over the hypotenuse, which is 3 over 5. The tan of theta, the tangent of theta, which is the sine over the cos, which is sine theta over cos theta, which is 4 over 5, 4 over 5, 4 over 5, 3 over 5, which is 4 over 5. We just, no, 4 over 3. Yeah, 4, which is 4 over 3. Why? We cancel 5. Perfect. So we just find that stuff. So now the next question, how is each primary triangle ratio related to the coordinate of A in R? We just answer that question. Now let's get rid of this. Now reflect the point. Reflect the point on y-axis to obtain a point C. Draw a line segment from C to the origin. Okay, and they are asking us what are the coordinates of C. Perfect. So first thing we will do, we will reflect our point A on the y-axis. So this is the y. We will reflect on this direction. So which will be, so we have 1, 2, 3. So it has 3 points out from the y-axis. So we will do the same thing. 1, 2, 3, which is this. So we just can say this is our C. So we will draw a line from there up to the origin, as they are asking us. Okay, and they are asking us what are the coordinates of C. Basically, and you can see that from the graph, that C have coordinates with which are x is what is minus 3. So here x, and y is 4. So minus 3, 4. Okay. Draw a line perpendicular. Draw a line perpendicular to x-axis to C. Okay. To reflect the tangent. the triangle. Label the intersection of this line and the x-axis with the D. Use your answer from step 3 to write primary triangle for COB. So they need us to find that for COB, which is here, which is this angle. No, let me use another color. For example, you can use this. So this angle. Okay. So the first thing, we draw a perpendicular line, which is this. This is my D. Now, to find the trigonometric function for this angle, we can write because we see that here both this angle and this one have the same, like the same y. So their y is the same, and r is also same. So r is same as this r. So they have the same y distance and they have the same radius. That means they have the same cos. So the same sine, sorry. So the sine of my new angle, which is I can call it COB, is equal to the sine of my angle which is AOB. Same thing. But however, the cos of COB, okay, is because it has the x-axis is negative. They have the same r, but they have different x, which is just -1. So because they have same r and the reflection of the B and the D, we can say that the cos of COB is equal to minus the sine minus the sine of AOB. Okay, draw a line perpendicular to x-axis. We just did that. Perfect. So as you can see here, we just do some interpretation here. So the sine of this, my angle here, the one which is bigger than 90 degrees, have the same sine as its reference angle, but it has opposite cosine as its reference angle. And this one is in quadrant 1 and this one in quadrant 2. Okay, we can also have this drawn in quadrant 3 and 4. How we can do that? We just can draw our same thing. We need to have -4 and -3, and it will give us the same angle here, or -4 and 3, which is, so we can have -3 -4, or we can have 3 -4. This point E and this point F. Perfect, sounds good. So this is just the same one, but a little bit not that much. So let's go over some explanation. So as we said, if we have one angle theta, if we have one angle here, so the theta will be the same one as the reference theta. So they have the same one because they are in the quadrant 1, and for this, like the same angle, but in the second quadrant, I just said that before, it will have the same reference angle but with a different angle which is bigger than 90 degree, and in this case these two angles, this theta, we can name it theta 1 and theta 2. So theta 2 and theta 1, they both have the same sine, but they have opposite cosine for this two. Here, from here to here, we just said that also before. Here we will have both of them, the sine is negative and the cosine is negative, but the tan is positive for this section. In this section, the cos is positive, the sine is negative, and the tan is negative. Okay, this is just another application, like if you want to apply more. So determine the exact value of 135. Okay, determining the exact value need to be really, and you have to understand this because there is so many questions related to this. So they are asking us to determine the exact value of 135. So the first thing you need to do is you draw your x and y axis. Okay, you draw your x and y axis. So where is 135? I know that 135 is bigger than 90, but it is less than 180. So what I will do, I will just put 180 minus 135, which gives me the how much? 135, which is 5, and 8 minus 4, which is 4. So it is a 45 degree to attend 180 degree. So to achieve 180 degree, we need to remove 45 degree. So my angle will be actually here. So this is a 45 degree. So my angle is this one. This is 135 degree. My reference angle theta r is 45. So instead of dealing with 135, because I know from my just previous lesson that whatever my 135 have, it will have the same, because it is in the quadrant 2, it will have the same sine with quadrant 1, but it will have negative cosine with quadrant 1. So I know from the beginning that my sine is positive and my cosine is negative for my angle of 135. So let's us work with our reference angle to find all that stuff. So what I will do, I will just draw one angle, one circle which has a radius of 1. Radius of 1. Okay, so let's see if we can draw a circle. So my circle will be like this. Yeah, okay, perfect. So I have a circle with a radius of 1, and if you just remember from the previous lesson that we did before, the video before this one, we said that a 45 degree is a half of a square, which is a half of a square, no, this. So it is a half of a square, and we just said that my 45 degree will be like this. So if I have this is 1 and this is 1, so this will be how much? R is what? Is R square is 1 square plus 1 square, which is 2. So my R is the square root of 2. So I know this is the square root of 2. This is my 45 degree. So the sine of 45 degree is what? is the opposite divided by the hypotenuse, which is 1 over square root of 2, and the cosine 45 is 1 over, same thing, square root of 2. So from this lesson that we learned it before, I know that the sine of 45 degree is 1 over square root of 2. The cosine of 45 degree is 1 over square root of 2. And we just said that our angle 135 will have the same sign as the reference angle, which is 45, but it will have a negative cos. So immediately I can just say that the sine of 135 is 1 over square root of 2. The cosine of 135 degree is minus 1 over square root of 2. And we are done with this answer. And you can see that they are giving directly the answer here, but if you can see, this is with more in depth. So suppose that theta is one angle in standard position with terminal arm in quadrant 3. So this is very important information. Quadrant 3, you all know it's this one. So my angle will be in this area. So what are the exact value of sine and tan of theta? So let us draw a very nice diagram to see that. So this is my x and y, and my cos, you know that cos, like for any angle, you know that the cos is the adjacent, no, not O, the adjacent over the hypotenuse. And I have here my cos is adjacent over hypotenuse, and they can see here it's minus 3 over 4. So I know my A will be minus 3 or 3, and my H will be 4 or minus 4. So how I will know that? From here, because they told me, they are telling me that my angle, terminal angle, is in this quadrant. So I know my angle is like this. Okay, so in this area, my cos, my x should be negative. This x in this side is positive. So from here I can know my A is minus 3 and my H is 4, because always my R is always positive. So I can just write that here. So I can say this is 4 and this is 3, minus 3. Okay, by using Pythagorean theorem, I can find my my y. How much is my y? So to find y, let's just clean this thing. So how much is my y? So I know that hypotenuse square is equal to my, I can say this opposite. So it's equal to my opposite square plus my adjacent square. So that means my opposite square is my hypotenuse square minus adjacent square, which is 16 minus 9. So minus 3 square is 9, which is how much? 7, which is 7. So that means that my opposite is square root of 7. So I know this is the square root of 7. So this is square root of 7. And because it is in the negative side of my y, this is negative, y this is positive, so it will be minus the square root of 7. Perfect. So now they are asking me to find the sine and the cos. So let's draw our real triangle so we won't be confused. So my triangle is like this, okay, and is like this, okay, it is like this. Okay, good. So this is minus 3, no, this is minus 3, this is 4, this is minus square root of 7. So the sine, this is my reference angle. This is theta r, theta r. So the sine of my theta r is what? Is this over this. So which is the minus square root of 7 over 4. Okay. Which is actually the same one as my the cos, my theta is minus 3 over 4. The tan theta is minus square root of 7 over minus 3, which is my square root of 7 over 3. So let me clean this thing. So we just find that the sine of theta is the sine of theta is minus square root of 7 over 4, and the tan of theta is minus square root of 7 over 3 minus 3, which is square root of 7 over 3. Good. So I hope this is the right question. This is so the cos is 3 over 4, yes. So the sine, so this is my y, and so the sine is minus square root of 7 over 4, and the tan is, yeah, over 4 here, sorry. Yeah, it's for 4 over 3. Good. So determine the value of sine theta, cos theta, and tan theta when the terminal arm of a quadrant angle theta coincide with the y-axis with 90 degrees. Very important question, and it is a little bit tricky. So you draw your x and y axis, okay, and they are telling me that my angle is here, okay, and it fell down on the same one. So what you can see from here, that my r is the same as my y, because this is my y and above it is my r. So they are both of the same. So the sine of 90 degree, we all know, is y over r, which is 1, and the cos of 90 degree is what? Is x over r, but x here is 0, there is no x, so it will be 0. Okay, the tan of 90 degree is 0 over 1, which doesn't make sense, so it is undetermined. Good. Okay, so now let's see. So you can do the same thing for 180 degree, or even 270 or 360. So solve for angle. So solve, that means we need to find, solve for the angle, that means we need to find theta. So they are giving us, for example, the sine of theta is a half. So let's see how it's look like. So let me draw my x and y axis. So they are telling me that the sine is a half. Okay, perfect. So from here you need to know how to use your unit circle. So the first thing you need to do is draw a circle that have a radius of 1. So I will draw my circle like this. Okay, and my circle have a radius of 1. So from here up to here, so from here to here is 1. And this is a half. Oh no, this is a half. From here to here is 1. So this is a half. So they are telling me the sine of theta is 1 over 2, okay, which means 0.5. And I know that, like, if I am using my previous knowledge from previous lesson, it's so my half is here, so my y is here, so this is my half, so my angle will be this one. So this is my theta I'm looking for it, because they are giving me the sine is a half. Why? Because I know that the half sine is the opposite over the hypotenuse, and my opposite is a half, and my hypotenuse is 1, or my r is 1. Okay, my r is 1 because I just said before, to make my life easy, I will use a circle with a radius of 1. Okay, so this is my half. So by applying my previous knowledge, which where I use a triangle which was like this. That was my 60 degree here, 30 degree here, and 90 degree here. And that triangle told me that this is 2, this is 1, this is so we find that my angle was 30, so the sine of 30 degree is 1 over 2. This is 1 over 2. So in this case, I have my y and I have my r. You can just apply, you can just write from whatever you know from before, that the cos of 30 degree is square root of 3 over 2. But if you want to find it, you can just use your previous triangle, which was like this. So you have a triangle with length of 2 in this side. You have let me write exactly how it was before. Oh no, so like this. We have a radius of 1, okay, and we have 2, a length of 2, and we said that this give us 60 degree, this is 30 degree, this is 90 degree, and we said before that 1 square plus y square is equal to 4, which is 2 square. So y is equal to the square root of 3, 4 minus 1, which is square root of 3. So from there we find this is the square root of 3. So, and if you want to see the sine and the cos of it, you just write the sine, for example, for this angle. The sine of theta is the square root of 3 over 2, which is the opposite over the hypotenuse. And this angle was 60, so the sine of 60 is square root of 3 over 2. And we said that the opposite is the cos of 60 is 1/2, and we said that the sine of 30 degree, this angle, the sine is the opposite, which is 1/2, and the cosine of 30, it's square root of 3/2, and this is exactly what we have here. So basically we know that my angle here is 30 degree. So I can write it here. So this is 30 degree. Oh no, this is 30 degree. Okay, so I find the sine is a half, and I find my theta is 30 degree. But as long they are telling me that my angle is between 0 and 360, this answer is just for theta between 0 and 90 degree. So I should increase my like the radius of my angle. So let's draw another one that have the same sign. So which angle have the same sign is this angle. So this angle from here to here, no, let me use this one. So this angle from here to here have the same sign, which is 30 degree. The sine is always a half, same as this one. So they both of them have sine of half. So now I need to find how much is this angle from here to here. So this angle is 180 minus 30 degree, which is 150 degree. So my full answer is these two angles. Why I am not going to this section? Because in this section my sign will be negative, so I cannot use it because they are telling me that the sign is a positive. Same thing here, my sign is negative. For this question, you can use it do it by yourself, but you can see from here that the cos is negative. So you have a negative cos. That means you need to use the quadrant, which is this side. So the cos should be in this side. So you will have angle this side and this side. And because they are telling you your theta is just between 1 and 80, so you are not allowed to use this section. So your answer will be just this one. Yeah, you can see here is theta is just between 0 and 180. Okay, so example 6, given this angle. Oh, this is just very easy question. So you have the cos of an angle is this minus 0.6753, and the angle is between this. So determine the measure of theta. So this is a cos. As I said before, this is a cosine. So your cosine, so this is a cosine of angle, and they are telling you the cosine is negative. The cosine is negative just in this section. Okay, so this section the cos is negative, and because you are working with 0 up to 360 degree, so you need to use both these two angles. So your first one will be here, the second one will be here. So what you will do, you will find which angle actually have a cosine of 0.67. So you find angle which is have a cosine of 0.6753, not minus. Okay, when you find it, you will get the reference angle, and this reference angle will actually tell you where is your angle. So we will put 180 minus your reference angle that you will find from here, and it will give you the exact value of your angle. Okay, this is what they are doing. So they use the calculator to find the angle of 0.67. Don't use minus. it won't give you anything. Use this one, okay, and it will give you the angle is 47.5. After that, this is your reference angle, so you just do 180 minus that, it will give you the angle here, okay. And same thing, you will get the other one, but just adding the reference angle to 180 to get the other one here. Okay, perfect. So now let's do some exercises. So the first question is actually asking you to sketch one angle in standard position for this point. So for this exercise, the first thing you do is you draw your point. Where are your points in the quadrant? So draw them. Like for the first one, for this one, your point should be somewhere here. So you need to have 2 on x-axis and 6 on y-axis. So your point will be here. After that, you draw your end leg, which is like this, and your theta will be like this. For example, for this one, for B, your x is -4, so it will be in this section, and y is 2, which is 2 here. So your point will be here, and you draw your end leg for your angle, and your angle will be this one. This is also similar for this one. It's easy, you can do it. So for this one, they are asking you determine the exact value of sine, cosine, and tangent. Okay, the first one, this is a very simple one. You remember that your triangle is like this. So this is your triangle, and as we said before, this is 60. So you give it 1 here, and you give it 2 here, as we did in the previous one. So this one will be the square root of 3. So by applying the Pythagorean theorem, so the sine of this angle will be the square root of 3 over 2, and the cosine will be 1 over 2. And the tan is just sine over cosine. For this one is 225. The first thing you need to do is you find the reference angle. The reference angle is what? Is 255 minus 180, and it will give you the reference angle, and use the triangle. I think 225, let me do with this in calculator. So 225 minus 180, it will give you 45. So this is a 45 degree, and 45 degree, use your square rules, which is 1 here, 1 here, and you find this one will be the square root of 2. So the cos is 1, the sine is 1 over square root of 2, and the cosine is 1 over square root of 2. For this one, this is like you find also the reference angle, which will be 180 up to here, minus this one, it will give you this one. So this one will be a 30. So you've applied the same rule as the 60 degree and 30 square rectangle triangle that we used before, and the sine and the cosine will be the opposite of the that you have above. Just remember that in this section your sine is positive and your cosine is negative, should be negative. Here you have 90 degree angle, so your R and the Y are same, so R is equal to Y. So this will tell you that your sine of 90 degree is 1, the cosine of 90 degree is 0. Okay, the coordinate of point P on the terminal arm of each angle are shown. We write exact trigonometric ratio of sine, cosine. Very easy stuff. So you have here is 4 and this is 3, this is 4. So you need to find this one, this section, by applying the Pythagorean theorem, which is 3 square plus 4 square, which is 25. 25, square root of 25 is 5. So you have, this is 5, this is 4, this is 3. So from there you can say the sine of this theta is 4 over 5, the cosine is 3 over 5, and the tan is 4 over 3. Same thing here. So you have minus 12 minus 5. So you have minus 12 from here is minus 12, and this is minus 5. You need to find this one, which will be this one square plus this one square. You will get this one and square root it, and you apply the same rule we did here. Very easy thing. So the same thing, for all this problem, you need to find your r by applying the Pythagorean theorem. After that, you just apply the rule of sine and cosine. Okay, for each this description in which quadrant determine the so this one tell you to see or to say which quadrant is the sine and the cosine. So the first one, the cosine ratio is negative, and the sine ratio is positive. So this is a quadrant 2. The second one, the cosine ratio and the tangent ratio are both positive. So this is quadrant 1, and so on and so forth. For example, for the last one, for D, the tan ratio is negative and the cosine is positive. Then see, this is a quadrant 4. Okay, determine the exact value of sine, cosine, and tan if terminal arm on the angle in standard position pass through the point. Same thing as we did before. It's just the same thing. Without using calculator, state whether each ratio is positive or negative. So this is a very, very easy one also. It just the tan is in quadrant, the tan is the angle is in quadrant number 2, so the sine is 155 is positive. For this one, the cos of 320 is positive also. Why? The angle is in quadrant number 4. For 120, the tan of 120 is negative. Also, the angle is in quadrant number 2. For the 220, the cosine of 220 is negative. So, one angle is in standard position such as the sine is 5 over 13. So you know that y is 5 and your radius r is 13. So you need only to use the Pythagorean theorem to determine your x, which is the x-axis. And when you find it, you determine the reference angle from that. And you will get one angle like, I think, yeah, because we are using the same one, sine of 5 over 13. So you theta, your angle theta is, use your calculator, sine to the power of minus 1 of 5 over 13, and you will find, I think, let me do it, yeah, it will give you 22 degree 0.619, and then the nearest degree in quadrant 1 is 23 degree. In this quadrant 2, theta is 180 minus 180 minus 20 degree, and it will give you the angle is 157 or something like that. 157. Okay, so solve. Yeah, this is like a number 9. Number 9 is very, very important. So number 9. Let us actually do this number 9 because so many questions are like this. The diagram. Okay. Solve each question for. Oh my God. Solve each question. So solve its equation for this one. So we have a cos equal 1/2. I think we did this before. So the cos half is either 60 degree, is either, so a half, the cos is a half, so like this. So it will be 30 degree like this. No, it's not 30 degree. Let's draw it exactly. So this is my repair. So the cos is a half. So let me draw it like this. The cos, this is 1, this is a half. So my cos is a half. So the angle is 60 degree. This is 60 degree. Okay, and same thing. Which one have the same cos a half is this angle downside. Down one also have the same thing. So both of them have a positive cos, which is a half. So this is a 60 degree and this is minus 60 degree, or this is 360 minus 60, which is 300. So this is 60 degree or 300 degree. Okay. Number 11. Determine the value of x, y, and r, sine, cos, and tan in each example. So very easy thing, very easy stuff. So you already know this is your p. So p is minus 8. So this is minus 8, and this, no, let me use actually, this is minus 8 and this is 6. So this is my triangle, so I'm using this triangle. So this is 8, this is 6. So my r, I have to determine my r. So my x is minus 8, y is 6, r is this 8 square plus 6 square equals r square. So just you square it to get your r. And when you got your r, you can find, for example, I don't know how much r, but let me use my calculator to find. So r is 10. So r is 10. So the sine of theta is the opposite, which is 6 over 10, or divided by 2, 3 over 5. The cos of theta is the adjacent, which is 8 over r. R is what? R is 10, which is 4 over 5. And because it is quadrant 2, it is negative 1. Okay, so the cos is minus 4 over 5. The tan theta is minus 3 over 4. Good. I hope this helped you, and see you.